GeopByte.
Look at the another important problem asking like this. A moving block having mass m collides with another stationary block having mass 4m. A moving block of mass m maintaining the velocity, of course, not the, it is moving, and it is the stationary one. The mass is 4m. The lighter block comes to rest after collision. Block comes to rest after collision. This is becoming, right, the v1 is becoming 0. This is the velocity u1 when when the initial velocity of the lighter block is v, u1 equal to v, u1 equal to v, right? After collision, lighter block comes to rest. Then the value of coefficient of restitution will be, what is the coefficient of restitution? Then this may be the 4m mass maintaining the v2 velocity, v2 velocity, right? Now here u2 is equal to 0 because it is stationary. It is stationary. It is at rest. First, let us decide the v2 in terms of u1. For that, let us apply the conservation of linear momentum using conservation of linear momentum. That is m into u1 is equal to 4m into v2. M is cancelled. Here v2 equal to u1 by 4. Then what is the coefficient of restitution? Coefficient of restitution. Coefficient of restitution E equal to velocity of separation. Velocity of separation dividing by velocity of approach. Velocity of approach. Velocity of separation is v2 velocity minus 0 by velocity of approach is v, that is u1 minus 0. u1 minus 0. v2 equal to what? v2 equal to u1 by 4. Here u1 by 4 by u1. Of course, here u1 is given v by 4 by v cancelled. It is a 1 by 4. It is equal to 0.25 equal to 25%. That is the coefficient of restitution, 0.25. Look at the options. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. It is asking like this. Which of the following statements are correct? You are asked to decide the correct statement. Center of mass of a body always coincides with the center of gravity of the body. Dear friends, remember, center of mass of the body is coinciding with the center of gravity only when it is maintaining uniform gravitational field, not always. Center of mass of the body coinciding with the center of gravity only where the gravitational field is uniform. Therefore, always is not correct. First statement is not correct. Look at the second one. Center of mass of body is the point at which the total gravitational torque on the body is 0. Absolutely correct. At the center of mass, total gravitational torque is 0. Right? Second statement is correct. Look at the third statement. A couple on a body produces both translational and rotational motion in a body. No. A couple on a body produces only rotational motion, not translational motion. Therefore, third statement is not correct. Mechanical advantage greater than one means that the small effort can be used to lift a large load. Absolutely correct. Means indirectly is asking mechanical advantage is more than one because mechanical advantage is what? Look at the what screw jack or jockey. This is the jockey. It is for lifting the large weight like car weight by means of a small force. Whatever the force we are applying, to the screw is called effort. Whatever the small force we are applying to the screw is called effort. Effort. This weight of the car is called load. Then the ratio between the load and effort is called mechanical advantage. Let me write that point clearly. Mechanical advantage equal to load lifting dividing by effort applied. By applying small effort, large weight can be lifted. Since load lifting always more than effort applied with the help of screw jack mechanism. Therefore, mechanical advantage, this I can write as MA, always more than 1. That's what is written as fourth statement. Mechanical advantage greater than 1 means that small effort can be used to lift a large load. Absolutely correct. So, second statement and fourth statement correct. Option A itself is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A rigid ball of mass m strikes a rigid wall at 60 degrees and gets reflected without any loss of speed as shown in figure. Look at the figure given. The ball is striking the vertical wall at an angle 60 degrees with respect to horizontal, and it is reflecting with the same angle. Okay, then the value of impulse imparted by the ball on the ball, the similar problem already have done, if you remember. Okay, means this kind of problem also, right, repeating. Now for that, impulse, it is asking impulse, as you know, impulse equal to, right, change in momentum, not rate of change in momentum. Rate of change in momentum is force. Impulse equal to just change in momentum. This mv is developing a momentum like this with a magnitude mv cos 60 degrees. This mv is developing the momentum in the opposite direction with the same magnitude cos 60, mv cos 60. Therefore, change in momentum means mv cos 60 plus mv cos 60. It is equal to 2 mv cos 60. It is equal to 2 mv. What is cos 60? 1 by 2. This 2 cancelled. Finally, impulse equal to mv. Look at the option A. Option A is absolutely correct. Okay? Simple problem. Similarly, let us take the another important problem. Look at the problem. It is asking like this. A bullet of mass 10 grams moving horizontally with a velocity 400 meter per second. Mass of the bullet is given 10 grams. It is equal to 10 into 10 power minus 3 kilograms. And its initial velocity equal to 400 meter per second. Strikes a wooden block of mass 2 kg which is suspended by a light inextensible string of length 5 meters. It is like this. A weight is connected to a string. This is the weight or block. So it is given block, right? It is given what? Uh, Suspend light inextensible string, wooden block. This is a wooden block. Wooden block is suspended. Therefore, the initial velocity of the wooden block is equal to 0. Mass of the wooden block is given. How much is given? Mass of the wooden block 2 kg, 2 kilograms. 2 kilograms. Mass of the wooden block is given 2 kilograms, and it is initial velocity of the wooden block equal to 0 because it is just suspended. As a result, the center of gravity of the block is found to be rising to a vertical distance of 10 centimeters because of the right, bullet hitting, right, because of the bullet force. This is look at the bullet. Because of the bullet, the wooden block center of gravity shifting through what distance? 10 centimeters. 10 centimeters. This is the 10 centimeters. This I am writing as h. Then the speed of the bullet after it emerges out horizontally from the block. That means with what velocity the with what velocity the bullet is coming out from the wooden block. That means final velocity of the bullet equal to how much? For that, let us connect the what uh, conservation of momentum principle. Conservation of momentum is conservation of momentum. Let me write it clearly. Mass of the bullet into initial velocity of the bullet plus mass of the wooden block into initial velocity of the wooden block must be equal to mass of the bullet into final velocity of the bullet plus mass of the wooden block into velocity of the wooden block. Here velocity of the wooden block equal to velocity of the wooden block equal to velocity of the wooden block equal to root over 2gh. It is equal to root over 2. Since g not given, since not given, take 9.8 multiplied by h is 10 centimeters, means zero point 0.1 meter. Now it is root over 19.6 into zero point 0.1. It is equal to root over 1.96. It is equal to 1.4 meter per second. Meter per second. Now let us substitute all values. Mass of the bullet 0.01, point 0.01, 10 by 1000, 0.01, correct. 0.01 multiplied by initial velocity of the bullet is given 200 meter per 400 meter per second. 400 plus this is becoming 0 is equal to mass of the bullet is 0.01 into velocity of the bullet plus mass of the wooden block 2 into 1.4, 1.4, right? Uh, root 2 GH, correct. Then it is 4. 4 is equal to 0.01 into velocity of the bullet plus 2.8. 2.8. So here it is right 4 minus 2.8 is equal to 0.01 into velocity of the bullet. It is 1.2 is equal to 0.01 into velocity of the bullet. So bullet velocity equal to 1.2 divided by 0.01. It is equal to 0.01. It is equal to 120, 120 meter per second. With that velocity, bullet is coming out from the, with that velocity, the bullet is coming out from the wooden block. This is the bullet. Okay, this is the bullet. That bullet is coming out with 120 meter per second. Look at the options. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. It is asking like this. Two identical balls A and B having velocities 0.5 meter per second and minus 0.3 meter per second. That means mass of the A equal to mass of the B and initial velocity of the A equal to 0.5 meter per second and initial velocity of the B equal to minus 0.3 meter per second respectively. Collide elastically. That means elastic collision. Elastic collision in one dimension. In one dimension. The velocities of B and A after the collision respectively. Final velocity of the A is VA. Final velocity of the B is VB. Right? It is asking what is the final velocity of the B and final velocity of the A respectively. As you know, when two identical balls are colliding with different velocities in elastic collision manner, elastic collision, just velocities are exchanging. Velocities are exchanging means UA is becoming VB and this UB is becoming VA. That means VB equal to 0.5 meter per second, VA equal to minus 0.3 meter per second. That means when elastic collision is happening between the two bodies which are maintaining the equal masses, just velocities are exchanging. Look at the options. Option B is absolutely correct. 0.5 meter per second and minus 0.3 meter per second. Understood clearly? Yes.
GeopByte.